Well, hi, and thanks for joining me in my shop here. I'm going to continue with this very nice vacuum tube amplifier. It has a 6V6 push-pull for an output, and it appears to be in great shape. I've done a very preliminary test on it. You may have seen it in the earlier video. And right at the end of that test, we started hearing some funny sounds come out of this amplifier, or so it appeared. So today we're going to give the amplifier a good test and see if those sounds show up again, and check out what might be causing those problems. So I already have a speaker connected. It's just this little speaker. It's not a big one at all. And a big amp, it should have a big speaker, I suppose, but it doesn't. And I see something curious here, and that's this connector here. It's a little bit of an oddball. This capacitor doesn't, it just looks a little odd to me, this feature here. It's like a connection straight into what I'm guessing are one of the two output tubes. No, that's right into, I think, a 6SN7. So that's the preamp for the two 6V6s. So just curious about that, that's all. So and I'm going to need a music signal, come to think of it here. So I think what I'll do is first we'll use we'll just sort of inject a tone type signal into it, but eventually we're going to have to listen to something, you know, natural through it, music or something like that, I think. But this can be our signal, input signal, and let's see. And just looking at the different inputs up here. Yeah, it's a pretty simple matter of that goes to ground, and this goes to any one of these inputs up above here. Volume is down, switch is off, the set is not plugged in. I will plug it in. I have my safety ground light ready for action, but this unit has a power transformer, so it should not have a hot chassis. Should not be the case. But just to be doubly sure, switch is off. Okay. Put the power on. Restricted power. And we'll just be doubly sure here that there really can't be any case voltage. As long as I have that wire connected there. It's a big zero. Okay. Let's switch it on. The light works. I was a little doubtful about that light because it's pretty darkened, but still good. Okay. Their voltage is about 80% of line voltage right now. And it's just very slowly heating up with that reduced supply voltage. You can see it in this meter here, which looks like it says 0, but really it's 100 volts at the bottom of that scale. So it's just a little bit below 100 volts. Well, actually it's quite a ways below. Okay, we'll give it, oop, wrong switch, full voltage here. So there's some of that noise. Could be a tube in the tube socket, a loose tube in the tube socket. Okay, so I think what we're going to do, I'm a little nervous running the set, thinking that one of these capacitors is going to pop in my right in front of me. We'll supply B plus from my controlled power supply, and we'll take a look at the leakage in the B plus circuitry. And that should either reassure me or start pointing towards trouble. This looks like a replaced capacitor. This capacitor here. It's possible all these bright yellow ones are also replacements. Okay, that should be down enough now. We'll test the voltage before we hook up the other supply. Okay, so I'm looking for a residual voltage on capacitors, the power supply capacitors. Let's see. Oh, there's nothing. Okay, there's no problem. Now, there's quite a few capacitors up here, one here and here. Which one would be the best one to hook up to? Probably any one of those terminals. Well, that's interesting. There's a terminal there that's missing a wire. There's no wire going to it, but it does look like it's been soldered before. That's interesting. Not sure about that. Be a little unusual to find a section of a capacitor in a radio like this not connected, unless it's been disconnected on purpose. Okay, so let's look for the rectifier tube here. Rectifier tube is the rectifier tube in its socket is really, really loose. The socket itself. It's down here though. Looks like we have a big inductor in the power supply. And what I'm looking for is a wire that leaves the rectifier and heads up to the capacitors. And I think I see it there. Yeah, I think I see the orange one right here. Tell you what I'm going to do. I'm going to turn the set on again. I'm going to read some voltages here. I think that might be a better move. I'm trying to inject the voltage right off the bat here. Let's do that first. Back in. Safety ground still connected. Power on. There we go. 200 volts, 250, 300, 375. So that is the initial capacitor. And this is almost certainly the second one. 300, 250, 190. I'm going to put this on AC. I'm not too sure about how well my meter works in separating AC from DC. Many meters are useless here. Oh, it looks pretty good. So according to that, we're getting a very low AC voltage. Very, very low. Right off the bat there. Yeah, I have some doubts about my meter working properly under these circumstances. 0. Wow. Okay, well that's good. That's what you kind of want. That suggests there's no hum level in this. Suggests no leakage also. I'm not so worried now. So let's assume that crackling is coming from a tube. Some kind of tube. We won't put my DC variable supply on it just yet. Now, don't want any loud pops here. Like that. It's not changing the scratchiness though, is it? Yeah, that didn't seem to be the source of our trouble there. Phooey, this is not the kind of thing that's easy to find. We know it's before the volume control though. Yeah. And also the selector switch. Makes momentary difference. Could be a dirty switch. Not so sure about that. I just don't think it's a switch. No. And it glides down on that setting. shouldn't be one particularly bad setting here. Well, that's interesting. This is something to look at. What's going on there? Okay, we'll turn the set off while we figure that out. I have the schematic. Okay, so that's switch setting 1, 2, 3. 1, 2, and 3. Now, according to this, that's yeah, right. A little hard to interpret the chart on the back versus the position on the front here. There's no indication on anything of these settings. So I'm on setting number, I don't know, 3. I guess it would call that 3. Well, you're going to have to poke around and figure it out. I'm going to guess the output from this switch is coming through this capacitor into this tube here. There's a few other spots in there too that reach that tube. That would mean I should be able to get a short between this point and one of these inputs here. Don't be fooled, that's the ground there. What is that? Yeah, that's the ground, so that's not at all that. That's just finding a ground. So much for that theory. Another one is this green wire here. Okay, this is the position that we get the noise. Huh. That's strange. Grounded. I think I'm going to study the schematic for a few minutes here. Smarten myself up a little bit. Okay, once in a while I kind of show the schematic and kind of explain it. And I don't do that too often. This particular amplifier is so classic in its design that it's worth going through. This is really a very, very, very straightforward amplifier. So let's do that really quickly. First of all, it's got 6 inputs, 1, 2, 3, 4, 5, 6 inputs, but it's got a 10 position selector switch. So what is it selecting with the other 4 positions, since it only needs 6 in the switch? And you can see in the switch that these positions are shorted together. So as the selector travels past these points where it's selecting the different inputs, it then comes to one that's just all connected together. What's going on at that point is you selected the magnetic input. Now, these selections don't do anything. This selector is moving, and what it's doing is selecting different RC networks here to change the tonal quality of the sound, and that's because back when these amps were made, the sound recording standards had not been set, and so a lot of these amps come with a lot of flexibility to select different standards or just to affect that in a dramatic way. So when you put on one record, you could select, let's say, the North American standard, and put on a different record, you could select some other standard, something like that. So when you're on a magnetic cartridge, it gives you all these different opportunities to change the tonal quality right at the input to it. So that explains why there's a 10 selector switch with only 6 inputs. Now, the signal works its way to this tube, 686, and the 686 is being used as a straight triode amplifier. Here's the bypass capacitor on the cathode resistor, so it's using a cathode resistor to produce the bias relationship between the grid and the cathode, and it's bypassed by this big capacitor. So we'll have to check into some of these things. Carrying along on this great big diagram. So here's the 12AX7 tube, and it's simply being used as an amplifier. And here it's coming in the front. It's coming in the first half of the tube, and then being fed around the output, around to the input here. And here's the bass control, treble control. These are very simple networks they have in here. Nothing too fancy going on. And then the output from the 12AX7, which now should be fairly strong, is fed straight into the grid of this 6SN7 tube, which in some cases you might use a tube like this to invert the signal to supply to the push-pull output, but in this case that's not what's happening. What's happening is they are amplifying it with this half of the tube. The signal is then fed around to the grid of the other half, which also amplifies it, and then the way they get the inverted signal for the 6v6s is one tube gets its signal from the plate circuit and the other tube gets its signal from the cathode. It's kind of like a cathode follower type arrangement, and that's how you get the inverted signals to go to the 6v6 output tubes, which then drive the big transformer at the end, and voila, we're done. That's a pretty straightforward tube amplifier. This is a good quality one. Don't think you can get really that much simpler and still have a good quality amplifier. So, okay, so how does that help us? Well, it explains the selector switch. It doesn't tell us anything about the hissy noise, and but it certainly lays out how we should approach troubleshooting this set. So let's operate it some more.